Hi everybody, welcome back. Today we're going to take on part 2 of graphing rational functions. That's section 9.3. We're going to kind of hit again the same stuff we hit in part 1, but this time I'm going to show you how to kind of speed your work along a little bit using a graphing calculator. Show you some tools that you can use that you can graph this, but we're still going to ask you to graph them manually, and I'll give you the toolkit to do that. Well, let's start here with this function, and as always before, we're going to have to do something here to find the asymptotes, and the calculator will not actually help you find those. In fact, it doesn't graph the asymptotes at all. So we're going to have to find those. So let's start with the vertical asymptote. Check to see if there's any holes at all, and then also see if we can find the horizontal asymptote. All right, as we look at this function here, we want to find out where the denominator is not going to be 0. So I notice on the bottom here, I can factor that. In fact, it looks like the top factors as well. This is the difference of squares on the top. That's x plus 2 and x minus 2. I'll just factor them both at the same time here. And on the bottom, this looks like x plus 3 and x plus 2. That gives me 3x, and 2 more is 5x. So there you go. There is our denominator. Now we have two different excluded values. X cannot be a negative 3, otherwise this factor would be 0, and x cannot be a negative 2. However, these are not both asymptotes, and I can tell that because the x plus 2's here are going to cancel. That means that this one, x plus 2, that factor, is telling us that this is actually a hole. And the other one is going to be a vertical asymptote. So let's go up here and write those in. The vertical asymptote is at x equals negative 3, and the hole is at x equals a negative 2. And we'll draw those on our picture. Your graph, by the way, on the calculator will not be able to graph either of these unless we do some special work. Now, horizontal asymptote. Let's go back up to the original problem. Remember, to find the horizontal asymptote, we have to ask the question, what happens as x gets very big? Okay, as x gets big, a million or a billion. In this case, we've got that on the top and on the bottom going on here, where we got x squared. This 6 is not going to have any meaning at all, really, and neither does the negative 4. 5x is relatively insignificant as well. So what we've got on the top here is very big number times a very big number, say a trillion times a trillion, and on the bottom also a trillion times a trillion, some very big numbers. Well, what's going to happen here? Well, we're going to cancel those trillions, cancel those trillions, and what's this equal to? Well, this is equal to 1. And as it turns out, when the highest degree on the top and the highest degree on the bottom are the same, then it's the ratio of the coefficients out front. In this case, it's 1 to 1, 1 to 1. If those coefficients were different, then we'd have a different number, but it's whatever that fraction of the coefficients is going to be. So it tells us that our horizontal asymptote, which is a y equals equation, is going to be at 1. So now we know where our vertical asymptote is and our holes. All right, we're ready to start graphing this thing. I'm out of room here, but I'm going to erase most of this, and then we're going to come back and see if we can graph this. We're going to need the calculator to help us a little bit. All right, let's see if we can graph what we've got so far. We see that we've got a vertical asymptote at negative 3. Right here, vertical line, x equals negative 3. And we've got a horizontal asymptote at 1. The hole, we're going to have to wait and do that a little bit later. Now here's the real beauty of having a calculator to help us with. As I go to make a table here of values, I notice I have a vertical asymptote at negative 3. And I need to pick some values on both sides. Let's say negative 4 and negative 5, and down here negative 2 and negative 1. This is a vertical asymptote because it's undefined there. Now, the beauty of using the calculator here is that if I take this number -5 and stick it into both, everywhere x appears here, that's an enormous amount of arithmetic we're going to have to do. So we're going to go ahead and put this into the calculator. So let's go find the calculator. All right, I've gone ahead and plugged in that equation into the calculator. And you can see that I've put the numerator in parentheses and I put the denominator in parentheses. This is vitally important because in any fraction, the fraction bar acts like a numerator. The fraction bar acts like a parentheses. The numerator is separate and the denominator is separate. If I don't put the parentheses here, order of operations will take over and it will do what, if I didn't put the parentheses here, it would end up dividing 4 by x squared and then all the other stuff would get added. So we've got to make sure you're using lots of parentheses as you do this problem. Now, we're going to go ahead and graph this and see what happens. I'm going to hit zoom standard here and see what the thing looks like. All right, there's our graph. And we see a pretty good picture of the graph here. It would be nice if we could draw in the asymptotes, both the vertical and the horizontal. Now, I'm going to change the window a little bit. I'd like to go over to the left a little bit here so that I can see a little bit more of the graph up there. So I'm going to hit window and let's go x minimum. Let's go over to say, oh, I don't know, -15 or so. You can try graphing it again. So I'm hitting graph. All right, there's my graph now. All right. If we can draw in the asymptotes here, it would really help us see what's going on. Now, as you know, we already calculated the asymptotes, and you can see that the calculator is not going to give those to you. So our asymptotes, one of them is vertical and the other one's horizontal. Let's go back to the y equals screen. And I'm going to put in that horizontal line. And the horizontal line, the horizontal asymptote was at y equals 1. So this is going to be a horizontal line. I'm putting it in a separate equation here. Let's see what that looks like. There it is. Now I'm going to change the color here because I want that to stand out a little bit. So let's go back to the y equals screen. Actually, it's red. That's probably pretty good. We'll leave that one as it is. So there's our graph. Now I'd like to also be able to put the vertical asymptote on here as well. The vertical asymptote is a line that stands straight up and down. And if you remember, right, vertical lines are not functions, and the calculator will not graph them as a function, but we can draw them. Let's go see how to do that. So I'm going to go to my main work screen, that's second quit, and it's empty right now, the second quit. And now we're going to hit the draw menu, and that's right above the program button. So it will be second draw, and you'll get this menu, second draw. And I'm going to go down and select vertical. And our vertical line was at -3. Our vertical asymptote was at -3. By the way, I'm going to put a subtraction sign in here. See how long that sign is? The subtraction sign is not the right sign. You'll get the wrong answer there. Put a negative sign in there. There you go. -3 and a vertical asymptote. And what it will do is it won't actually graph it, but it just snaps it into place. So let's hit enter. There it is. And it's snapped into place. And you can see that those are exactly where we would predict them to be. A vertical asymptote is right down the center here, and the horizontal is right down the middle as well. Now, once again, the calculator will not put those in. We have to be able to go find those to see where those are going to go. Now, let's just say you wanted to graph this with your manually and be able to come up with some ordered pairs. Okay? Well, we can do that if we use table. So I'm going to hit second graph, which is the table button, and I end up with these guys here. Now you'll notice there's some errors that are showing up here, and that's because those are numbers that are not allowed. If you recall, the -3 was our asymptote, okay, and the -2 was a whole. -3 was the asymptote, and number 2 was the whole. So we can pull other numbers from this table that will help us not to have to maybe do so much work and calculate all of this stuff manually. So I'm going to look at here and I'm going to go, well, -4 goes to 6. Let's put that here. I'm writing these down. -4 goes to 6 and -5 goes to 3.5. And then let's go the other way. -2 is also a whole. So I'm sorry, yeah, -2 is a whole, and -1 is -0.25, and then 2 goes to 0. So -1 goes to -1.5, and then 0 goes to, well, that looks like about -2/3. 0.6 repeating. We could go farther up the way here if we needed to. So I just jotted a couple numbers down, and we're going to go back and look at our table and plot these points. Okay? All right, here's our original problem again. And we've got our asymptote already drawn in there. We've also got the horizontal asymptote drawn. Let's plot a couple points here. -5, 1, 2, 3, 4, 5. -5 went to 3.5. 1, 2, 3. 3.5 would be about here. -4 goes to 6. 1, 2, 3, 4, 5, 6. -4 goes to 6. Okay. -3 was our vertical asymptote. We're going to have a hole here at 2, -2. -1 goes to -1.5. -1.5 would be here, and 0 goes to about 2/3, we said. Okay, so 0 goes to -2/3, which is about here. So we're going to go ahead and draw those curves in. We know the asymptotes are kind of determining where they're going to go, and yes, this is exactly what was shown on our picture, but this just allows us to be able to sketch this manually as well, just having a couple points to help us get the curve. We don't want the curve to be, too sharp a corner or anything like that. All right, finally, the last thing we have to do here now is we know we have a hole at -2. So right here at -2, I'm going to have to erase here and put a hole right here at -2. So there's our graph. What was the beauty of the calculator? Well, it allowed us to verify that our asymptotes were in the right spots. And also it allowed us to make a table here that we can sketch this thing manually. But the calculator will not do this vital work for us, finding vertical asymptotes, holes, and horizontal asymptotes. Let's review again. Vertical asymptotes and holes are where the denominator is not defined. In other words, the denominator cannot be equal to 0. So when we factored this, we found out that our two factors told us that x could not be a -3 and it could not be a -2. Why was there a hole at -2? Because the factors -2 canceled. When something cancels away, it becomes a hole. So this is the idea. Let's do another one. We're going to do pretty much the same thing a few times here today. All right? All right, let's take a look at this one. This was one of the problems you had on yesterday's assignment. I want to pull out kind of one new thing that might have puzzled you a little bit yesterday. But we're going to do exactly what we've done before. Now, nothing can be canceled here and nothing can be factored. So we're going to move right into finding what the vertical asymptote and any holes might be. And then we'll find also the horizontal asymptote here. Well, in the denominator, the only thing that would make this denominator 0 is if x was a -1. -1 plus 1 is 0. So this has to be an excluded value, -1. Now, I canceled nothing here, so there's no holes. And the vertical asymptote would have to be at x cannot be a -1. You notice sometimes I write cannot be equal to, sometimes I write equal, because the line itself is actually an equation, and it's just telling us it's a dotted line and it's not really equal to it. All right, so we have a vertical asymptote, and I can go ahead and start my graph. That vertical asymptote is at -1. Okay, and I need a horizontal asymptote. Now let's think about what happens to what happens to y as x gets very big. So on the top, I've got 5 times 1,000,000,000, and on the bottom, I got 1,000,000,000 plus 1. Well, the plus 1 doesn't mean much here. But as it turns out, the 5 has some value, because 5 times a very big number over the very big number, turns out that the x's would cancel, like 5 times a big number over a big number. Turns out that the big numbers, the billions or whatever, the trillions would cancel, and my my horizontal asymptote is actually 5 here. Y equals 5, and I know that because these two would cancel, a trillion over a trillion, 5 trillion over 1 trillion, well, that's 5. So in this case, our horizontal asymptote, the 5 actually had some meaning here. Okay, so we know that our horizontal asymptote's at 5. So here we go, 1, 2, 3, 4, 5. Going to have a horizontal asymptote right here, and no holes. Now, we could go ahead and probably plot some points pretty easy here, but just for the practice, let's go ahead and use the calculator again. We know that our vertical asymptote's at -1, so we're going to check out -2 and -3 and 0 and 1, but we're going to use the calculator to do that. Let's go plug this in. All right, I went ahead and plugged our function in, and you'll notice looking at the calculator here that I've done it 2 ways. The top way is correct, where I've put the numerator in parentheses and the denominator in parentheses. The bottom one is not correct. Especially the denominator needs to be in parentheses here, and I want you to contrast and see that the answer we're going to get is going to be different. So let's take a look at those with graphs. All right, the first one that's going to be graphed is in black, and it's correct. The second one in red is wrong. Here we go. Correct. And that is wrong. The red one is wrong. Let's go back and take a look at why that's so. Well, the graphing calculator understands the order of operations. And when it saw this problem, the way it's written, order of operations says multiply 5 times x, then divide that by x. Well, x over x is 1. It goes out. So this is 5 times 1 plus 1. 5 plus 1 is 6. If you look at our picture over here, you'll notice that that horizontal asymptote, or that horizontal line, 1, 2, 3, 4, 5, is at 6. It's graphing it incorrectly. So what's the point here? It is extremely important that we use parentheses for the numerator and the denominator. That fraction bar that you see in a problem that we've written manually is a parentheses. Both the top and the bottom have to be in parentheses. All right, let's clear this out. Now, if you recall, we already had a vertical asymptote, but we're going to have to draw that in. But our horizontal asymptote, if you recall, was at 5. So we're going to put a horizontal asymptote, a flat horizontal line at 5. And let's see if it's really in the right spot. Here we go. There's the function. There's the asymptote. You'll notice this asymptote is in red. I do that just to make sure we can see that it's different than the other. If you have a color, able to do colors with your calculator, that kind of is a nice thing to do. Now the last thing we need to do here, or the next thing we're going to have to do, is to draw our vertical asymptote. Well, we know that the vertical asymptote is not a function, so we're going to go ahead and draw we're going to draw that vertical asymptote, and it was at -1. So I'm going to go to my quit screen, and I'm going to clear that out. You got to go here. If you don't come to your main work screen, it won't work. So we're going to go second draw, and we find this menu. Number 4 is vertical, and our vertical asymptote was at -1, and hit enter, and it snapped it into place. It's in another color. That's good. So we can see our asymptotes look like they're in the right spots. Okay. Now, if I wanted to graph this thing manually, to make a manual graph here, I'd like to know some points. So let's go to table. So second table, and there it is. Just ignore the Y2 column because that was that horizontal line. We're just looking at the Y1 column. Now we know our vertical asymptote was at -1. There it is. It says error. Well, why is it saying error? It says that because dividing by 0 is an illegal operation in math. So we're going to check the numbers on both sides of this and just jot them down. So let's see here. -2 went to 10. And -3 went to 7.5. I'm jotting those down on my paper, my work over here. 0 went to 0, and 1 went to 2.5. Only need a couple points to kind of get the shape of this thing. And of course, -1 was the vertical asymptote. So we've got some dots here that are going to help us graph this manually. Let's go back and graph it manually. All right, I've gone ahead and jotted those numbers down that we pulled from the table. Again, that's second table. So here we go. We know the vertical asymptote is at -1. At -2, it's 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops. -2 is at 10, way up here. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My marks are not terribly evenly spaced here, and -3 is at 7.5. -3 is at 7.5. 1, 2, 3, 4, 5, 6, 7.5 would be right about here. So we can see those two dots, and it's going to be up in this quarter up here. You can see that we never really know what quadrant they're going to be in until we start plotting points. Down here, 0 went to 0, and 1 went to 2.5. 2.5 is right here. So here's our other graph. Okay. And we had no holes. Okay. So it's the same idea on all of these. You have to come up with the vertical and the horizontal asymptotes, be able to graph them on your graph, and then you can draw a picture of them. I'm going to ask you to go ahead and make these pictures manually, even though you have the calculator at your disposal. So I want you to be able to come up with this table, but you don't have to do all the arithmetic. That's the good thing. Let's do another one that's a little bit odd. All right, here's one from the homework for tonight. You can take a look at this guy here. As we look at the denominator here, we can see that there are going to be 2 excluded values. That means we're going to have 2 values, in this case vertical asymptotes. I could set each one of these equal to 0 because neither of these factors can be 0. But we can kind of see now at this point how to tell that these are already easy to tell. X can't be 1. So x cannot be equal to 1. So we're going to have a vertical asymptote at 1. And x cannot be a -5. So we're going to have a vertical asymptote at -5. Okay? Now, we didn't cancel anything, so there are no holes. I'm going to write none there. And now let's look at the horizontal asymptote. This may be the thing you need the most work with. Okay? We're asking the question, always, what happens to y as x gets very big? Well, if x gets very big, I've got 3 over a huge big number, the 1 means nothing there, times a very big number, again the 5 means nothing. This number on the bottom is bigly big. It's a huge number, and it's like trillions and trillions. On the top is 3. And let me just use my example again here. If you owed somebody a total of trillions and trillions of dollars and you paid them $3, that's totally insignificant. So this is actually 0. 0 basically over a big, big number. Now try to get a hold of that. So in other words, our y is going to be equal to 0. This is basically 0. So we're going to write that horizontal asymptote in there. So now we can start our sketch here. And I'm going to do that. I've got a vertical asymptote at 1. I have a vertical asymptote at -5. 1, 2, 3, 4, -5. Kind of almost off the page here. Move it over just a little bit. And we've got a horizontal asymptote right at 0. Okay. Well, I could leave the just have the x-axis serve as that, but I'm going to put a little dotted line here just so I know where that is. I don't forget about the fact that that horizontal asymptote is right at 0, where the y value is 0. Now we're going to make it, okay, but we're going to pull this table from our calculator. Before we do that, let's go ahead and graph this thing. I'm going to put it into my calculator. All right, I've entered it into the calculator here the way it's shown on my paper, but can you tell that this is incorrect? Something wrong here. What is it? Well, according to the order of operations, I'm dividing by x minus 1. I'm not dividing by x plus 5. I'm multiplying times x plus 5. So I need to tell my calculator that I'm dividing by the entire denominator. So if I forget that, I can go in here and I can add that in here. So I'm going to take my cursor right over here where I want to add another parentheses. Now if you don't remember how to do that, you're going to hit the delete button right here. We're going to insert. Second insert will allow us to insert something in there. So we're going to insert, second insert. Now you notice the cursor's changed a little bit, and I'm going to insert a parentheses. It moved everything over. Then we're going to go out to the end out here and finish off the parentheses. They're not really needed at the end, but just to make a point here. Now, this is correct because the whole denominator is being divided into 3. Now, let's see what the graph looks like. Wow, okay. This is odd. Well, we can see for a fact that it does, in fact, have the horizontal asymptote is right at the x-axis, and there's 2 vertical asymptotes in here. We don't really need to draw the horizontal asymptote because the x-axis is acting that way. But let's draw in our vertical asymptotes. So I'm going to go, once again, I'm going to go second quit. Let's clear out the last one. And I'm going to go second draw, vertical. One of our vertical asymptotes was at 1. Let's graph that one. Now it snapped it into place in blue there. Let's go put another one in there. So second quit. Let's put a second one in here. So second draw, vertical. The other one was at -5. And let's snap that in there as well. All right, we see both of our vertical asymptotes. By the way, if you want to get rid of a vertical asymptote or you make an error and you need to do it again, you may have to go out and start a graph over again by changing the window or something. But we can see that our vertical asymptotes are clearly here. Okay? Now this graph is a bit unusual. It's got 3 branches. Of course, that makes sense because we had 3 regions. One left, center, and right. So I'm going to need to make a table of values that's quite long here. And I'm going to pick some values from the table. I've got a vertical asymptote at 1 and one at -5. So let's take a look at what it says in the table here. So second table. Notice there's a couple of errors on here. Those are by vertical asymptotes. See where the errors are written? So I want to check out -6 and -7. Negative 5 happens to be my vertical asymptote. Negative 4, I'm going to check out negative 3. And then I'm going to make an extension on my table and check out a couple numbers on the other side of 1. How about negative 1 and 0 and negative 1 and 0, and also 2 and 3. Okay, so we've got quite a few values we're going to jot down here so we can write them all out. Negative 7 is about 0.19. Well, let's just call it 0.2. Our graph's not going to be that accurate with my pen anyway. Negative 6 is about 0.4. I'm just going to round that off. Negative 4 is at about negative 0.6. Negative 3 right here is at about negative 0.4. Again, I'm rounding these because my graph is going to be hard to get too accurate with my pen. And I'm jotting these down on my board over here so you can see those in a second. Negative 1 goes to negative 0.4. 0 goes to negative 0.6. 2 goes to 0.4. And 3 goes to about 0.2. Okay, so I've got all those numbers jotted down and I can take them back to my graph. So here we go. Alright, so here's all my numbers. We're going to have a lot of stuff to graph here. So negative 7 goes to 0.2. Well, let's make it 1 here. Negative 7 goes to 0.2. Well, that's about right here. Negative 6 goes to 0.4. It's not much above it, not even about half. Negative 5 is my vertical asymptote. Negative 4 goes to a negative 0.6. Okay, a negative 0.6. It's about here. Negative 3 goes to a negative 0.4. Right about here. Negative 2 I don't have on here, but negative 1 goes to negative 0.4. Oops, right about there. And 0 goes to negative 0.6, right about here. Then finally 2 goes to 0.4. And 3 goes to 0.2. So it's a little hard to tell, but if we try to stay and respect these asymptotes, it appears that this one is going to have a pretty sharp corner down here, and it appears that this thing actually comes in and turns and goes back down. Also has pretty sharp corners on it. This one appears to come in here and go out this way. Okay, now let's just say what that looks like. That kind of compares to the picture that we had before. Okay, so yeah, I haven't blown this up full size, but you can see that it is the picture. And notice that these angles on our calculator are pretty sharp angles on the graph. So we've done a pretty good job here of graphing this manually. Those numbers are, we could probably pick some other numbers too that would make it a little better, but that's enough. We're just kind of interested in getting it in the ballpark. And this kind of underscores why it's so important to actually look at your table, because if we didn't, we might be tempted to draw this graph with really big rounded corners like most of the graphs we've seen so far have, but this has got pretty sharp corners. So if we want some accuracy, using the table is a good thing to do. Now the final thing I want to talk about here is just take a look at what's happening here. I want to look at something theoretical a little bit. You'll notice that what happens when we approach an asymptote is this particular, let's say we're coming in from the left here, and we approach this asymptote, it's headed off to positive y infinity. And then it's going off to infinity, and then it comes back in at the bottom down here at a negative infinity. And asymptotes do that. They cause something to take off in one direction, and then it comes back in, sort of like from the other side of the stage. You know, if you're in a drama, you exit stage up and you come back in stage down. That's what's happening here. Same thing here. This one ends up exiting stage down and it comes back in stage up. So this is very typical, and this happens all the time. And so sometimes you could get a prediction. In fact, if we didn't have, let me just erase this. If we didn't have this lower graph here at all, we'll just erase it. If I didn't have this lower graph at all, I can tell by the fact that these two both went north. Both of these went north here. And since they did, they must have come in from the south. And I can predict that they would have come in from the other hemisphere. Okay? So this is pretty typical. The only time this doesn't happen is when the denominator has an x squared in it. A polynomial that has a double asymptote. They're both the same. Let's do one more, then I'll cut you loose. All right, let's take a look at this one. This is not part of your homework, but you may have a problem like this on your homework. We did one similar to this yesterday, but I wanted to underscore something. Sometimes graphs don't, these rational function graphs don't end up as being curves. Let's see what happens if we try to come up with our vertical asymptotes and our holes and our horizontal asymptote. As I look at this problem here, I notice that the top is factorable, and that happens to be a difference of squares, so I'll get x plus 2 and x minus 2 all over x plus 2. Well, I can tell from the bottom I'm going to have an excluded value. X cannot be a negative 2. Now you might assume that that's a vertical asymptote because it's an excluded value in the denominator. But look what's going to happen again. These are going to cancel, and anything that cancels changes from being a vertical asymptote to being a hole. So there is a hole at x equals negative 2. There's a hole there, okay? And there will be no asymptotes. There's nothing left down here, so there's none here. Horizontal asymptotes, or let's see, what happens as x gets really big? Well, as x gets huge, on the top, you got big squared, big times big, okay? Minus 4 means nothing. And on the bottom, you get big plus 2. Well, the 2 doesn't mean anything. What happens when we cancel here? We notice that a big number, this does not have an asymptote. It just goes off into infinity. So there is no horizontal asymptote either. And let's see why that's so. Well, if I cancel everything away, you know what I got left here is simply this x minus 2. Well, what is that? Well, that's a linear equation. And we can graph this quite simply by using the y-intercept as negative 2. The slope is 1, or a rise of 1 and a run of 1. And there is my line. So sometimes these rational functions don't graph as curves. It's a line. So be on the lookout for that. You know, sometimes when things cancel away, you end up with something other than a curve. But we don't want to forget that there was an excluded value at negative 2. So we got to go over here and put a hole right down here at negative 2. So I'm going to erase that area. Right about here, negative 2 is right here. There's a hole there at a negative 2. So rational functions are wonderful things to do. Get a hold of this. If you have any questions, please email me. Sometimes you're going to get, occasionally you'll get a graph that looks more like a bell shape, because every once in a while you'll get a graph that looks like a bell shape, and that's because sometimes things have a squared, a double factor on the bottom. They're both the same. Let's take a look at your homework. All right, tonight's assignment is number T, page 488. There's mostly even ones there. Again, if you need to check those out, the even ones, you can go online and look at those graphs out there on that website that I gave you for checking your answers. Enjoy your time into this. This is great. It's a very important skill to have. So please Please practice with your calculators to come up with your table, and also practice working with the draw menu. Remember, if you're going to use the draw menu, you have to go to your second quit screen first. Go to second quit and then hit second draw, and then you can draw. You're going to end up drawing vertical lines. Vertical. So second quit if you want to draw those vertical asymptotes. This is for drawing vertical asymptotes in there. Horizontal asymptotes, you can just put them in your y equals screen. So y equals whatever that number is, let's say it's 5. Okay, so horizontal asymptotes are easy to draw, and then the vertical asymptotes, you're going to have to draw those in. These are graphs on the horizontal asymptotes. So have a good time with that. Take care.